Okay, welcome to the smell. Um, let's go over what you need to know about the nose. Again, this picture you should already have completed and colored. Different from taste, where it's a modified epithelial cell that has the receptor protein. In smell, the actual receptor cell where the receptor sites are nerve cells. So neurons are the receptor cells. And looking at this picture, you smell something. Odorants are actual molecules that diffuse through the air. Perfume, other stuff, diffuses through the air. You breathe it up into your nasal cavity. Well, there is a thick layer of mucus. Here are epithelial cells that line the top of your nasal cavity, and interspersed in these, you can see that this is columnar, simple columnar layer. Interspersed in these are the chemoreceptors, or the nerve cells that are responsible for your smell. Now remember, says here it has cilia. Remember the definition of cilia. These are projections of the actual, they're not hairs, they are projection of the actual cytoplasm. So they are continuous with, they're not like on attached. So this cilia here, zooming in, has the receptor molecules. So once again, the reception of this, very similar to taste, is going to have specific receptors. And those receptors are, instead of for tastants, these are for odorants. O-O-O-D-O-R, odorants. Boy, that pen is horrible. Odorant receptors. And they're also called ORs, but that also often looks like OR in your notes. So odorant receptors. Now, they use a G protein coupled receptor, so it's still going to use the G protein, similar to taste, but here it's going to then activate a cyclic AMP, which is going to directly open ion channels for the depolarization. So, and it's ion channels to sodium, which is positive, and calcium. So you smell something, the ORs, or the odorant receptors, if they have the correct shape, the odorant molecule will bind. That binding creates a G protein signal transduction pathway that involves CAMP that will open other channels in the cell. Cyclic AMP, it's going to open up the ion channels, and that's how you get depolarization. That depolarization will then just pass the action potentials through the olfactory bulb. Now, as it turns out, humans have about 1,000 ORs. So, and just like taste, each cell has an odorant receptor specific. So this cell is expressing one of the odorant receptors, and then this cell is expressing another of the 1,000 odorant receptors, and then this cell is expressing another of the 1,000 odorant receptors. They don't express a bunch each, they express one type. To be able to express that, you have to code for that protein. So as it turns out, that means we have about 1,000 genes just for smell. And which, yeah, it's only 1/10 of how many genes a dog has for smell, but it's still a tremendous amount that we use for detecting smell, which is kind of neat. Now, this is, since your mouth is right there, it is connected to what's called flavor. So if you take your taste and you add it to what you smell, that is what equals flavor. So a lot of times things don't taste very well if your nose is clogged up. My son often holds his nose when he eats things he doesn't like, trying to alter their flavor. So there you go. That is how we smell and all of its glory. Signing off. I'm gonna continue eating my delicious lunch.